So in this video, I'm going to show you the tool named Docker Compose. So I'm now at docker.com, uh, you know, using Compose page for you to get a quick understanding of what exactly this Docker Compose tool does. So it's a tool, it's not another container technology or anything like that. It's something that comes on top of Docker as an additional tooling. It's an augmented tool that you can use for multi-container applications, as it states here. So Docker Compose is a tool that was developed to help define and share multi-container applications. It is often the case when you create an application, you will need multiple containers. So in usual Docker form, you can spin up a container multiple times, and that will be for a single applications most of the time, right? But it's often the case that your application will comprise of multiple services. For example, your application might want a caching method, you on top of the Python application, for example, and so forth. So how do you kind of link it together is what you can do with Docker Compose quite easily. It's not that you can't do with just Docker commands. We can do that as well. So if you the previous video that I created on Docker, we looked at how to run a simple Flask application, Flask API within Docker. So this is exactly what I followed through. I will post the link to that video below as well for your reference. So we ran commands like docker build and docker image ls, and then this command called docker run, right? This is for single application that's actually embedding Python and Flask, right? So that's all good. But what if you wanted to have this application work with MySQL, a database backed application? How do you connect MySQL with this particular container? So MySQL as a database is a separate container. So that's something that we didn't cover in the last video. However, I just touched upon it. So how do we do that is when you run the container, you use this link command. When you have your container up and running, you use this link command to link your MySQL container as MySQL to your main container that you are running as Flask app container. So this is good, this is cool. But what if you have like even more applications that needs to be up and running for this container to work? So you will have to use this link command, and it keeps on going, right? I mean, this command becomes longer and longer and longer. So that can be little cumbersome at some point, because often the case that you will have to stop this and maybe you have to run this again. Probably you'll have to keep this command copy pasted somewhere to run it again. So this is exactly what Docker Compose is addressing, because rather than you having to run lengthy commands like that when it comes to multi-container applications, what you do is you create a simple YAML file to define the services of that particular application, and how, and whether you need to do volume mounting, whether you need to link this particular other service with this main uh, container and so forth. So you define that in a YAML file, and then once you have that thing, you just run a single command and it will spin up all the necessary containers. Or you can also shut it down, and it happens then all at once, right? So the big advantage of using the Compose is you can define your application stack in a file, because the application stack will have multiple containers. You define all of those, keep it at the root of your project repo. It's now the version control, which is your project, and easily enable someone else to contribute to your project. Someone would only need to clone your repo and start the Compose app, and that's it, and the entire application will spin up. So that's the idea of Docker Compose. And okay, so now let's see how to install Docker Compose. So this says if you have installed Docker Desktop Toolbox for your either Windows or Mac, you already have Docker Compose. But Previously, as I mentioned in the previous video as well, Docker Desktop is no more free if you are running your machine in an enterprise level where there are more than, I believe, 250 employees or 200 employees in your organization, or your enterprise is having more than 10 million USD ARR per year. So if that is the case, you can't run Docker desktop tool anymore. But if not, you can just download and run it and experiment with Docker desktop. That's no problem with that. So instead of doing that, what I did was I installed Rancher desktop. The good news is that Rancher also brings Docker Compose, just as Docker desktop does. So I have it installed already, so I refer to you to look at my previous blog video as well, and see if you can just install Docker desktop, then you can do that. Otherwise, go install Rancher desktop, right? So to see if that is installed fine, you can use this Docker Compose version. It should bring up a command. Otherwise, you will have to see what to do with that. So also it does mention that if you're running a Linux machine, you will have to install it separately, because it doesn't come with the Docker desktop for Linux, right? So install Docker Compose. So you go here and it has the details of how to install Docker Compose for Linux. So let's see. So this Docker Compose command then. So I can see Docker. As you can see, I have it already. If I just do that, you will get the Docker Compose version. You can also do this. That should also bring the same thing. So that looks good. So now if you remember the previous application that I containerized, this is the file system of that. You see this Docker file is already there. In addition, I also have this Docker compose.yaml. So let's have a quick look at what it does. Right, so Docker Compose, this is the YAML file that I was talking about that defines the entire application's containers. So it defines the version. So at the moment, I think the version is of a higher value, version 3.7. You can do that also, but in my case, I have kept it as 3. That's fine. So I have then defined a section called services, under which you have main sections explaining what are the containers that requires to run this particular application. So my main container is this container named web. You can give whatever name you want, but I just named it as web. And it says build with the local directory, which means it will be looking at the Docker file in the local present working directory, so which I have already defined, because that's where you specify which images to download. The file system layer of the Docker is defined there for that particular container. And now I define ports 5000, because previously this was done as part of the Docker command here, Docker run command. You don't do that anymore. I mean, in the YAML file you specify your port port mappings, and in my case this should be changed to 8082 because my Python application specifies that, so I'm going to change that to 8082 here. And I also specify volumes, whether I need to mount that. Previously in the video also we looked at what is this volume mount, which again we specified here as part of the volume mount. Let me just show that again. So in the Docker run command, I specified that the local present working directory's API directory should be mounted to the app API directory of the container. Now you can specify that in the Docker Compose YAML file itself, because note there is a dot here which specifies the present working directory and the API directory, and then this is the containers folder and so forth. And then I specify links. So this is just like the link command that you have to specify when you run it in the run it as a separate containers, and you use the command line to do that. So you have to link it separately, these containers. If you have like multiple containers linked, you have to use a lengthy command. But here in this case, I am saying links, and I specify this Redis key for that. So the Redis key, I use this image Redis because I don't have a local image, but this Redis will be it's a standard one. Basically, someone from Redis has uploaded an image to the Docker Hub or somewhere as a central repository, so that now when I run it, it will just fetch the related image here in my local machine. So it says the links, one is Redis, and if you have more such containers to be linked here, you just can do one down the other and so forth. You get the idea, right? So now that means my application should be using Redis as well. So let's go look at my application. So previously I was looking at apis.py. If I go to the end, I specify this 8082, that's why I changed that 5000 to 8082. So basically the previous this particular Flask REST API, what it does is it just creates a few applications, stores that in memory, and then when you fetch it, it will show all those things. So I can also use Redis to do that. I mean, I can persist this value, persist the product information to Redis. So I can say for that I need these things. I'm gonna uncomment those. As it says Redis, I'm saying host and port of Redis when you want to run it, and cache. When you run this first time, I flush the cache. So when you always rerun this particular container, it will flush the cache for this particular application. And when you insert a new message, I increment the product count. So this is exactly what I do, and I specify a key here, and that's the key that it will be using to keep the cache. So this particular cache will increment the product count, so that's the key. And when I delete, I decrement it, and then go down. So there is a new thing called, when you actually get the product count, you can do this, and I have this particular, so I have to so this particular function or method just tries to get the product count 5 times, and it should just get it in the first go. But in case if there is some error happens, I do a small sleep and then go back and try that 5 times. So if it keeps on failing, we do it 5 times and then we give up, right? So that's exactly what is happening. So this is a separate command for the company, and company get, it will return company product masters as number of products and so forth. So which is a separate API that I have got here. So if this particular, if I use this API company command, API company resource, I should get the number of products now from the Redis. So let's run Docker Compose to see what happens. So let's move out. So let me save the file first, and then going back here. So now I, just like the previous blog post, I also got this Docker Compose blog post as well. So it also explains why those changes that I just did, why I need those changes and so forth. So that is explained here, and we already looked at the Docker Compose YAML file. So let's now run Docker Compose up -d. So that's how you will instantiate this Docker Compose, and that will read the YAML file and start the relevant images for you, right? So after that, I'm also running a Docker image ls and Docker ps, because it should now just be starting the relevant containers in one go. So you can also follow along this particular tutorial as well. and it explains the details, and it also shows how to run this docker compose hyphen. So let's just copy this and come back here. So let's first try to see what is there in my image list. I already have got this Redis. That's because in my previous command that I had. So let's remove that. Docker remove, let's say Redis. Okay, now it's gone. I should not have it. Now I'm gonna run, and just to show you, there's nothing in no containers actually running now. So docker ps. So next up is docker compose up minus d. So this is now going to pull Redis, as you can see, because it doesn't have it already. It might go pull Ubuntu because it won't do, it won't pull Ubuntu because I already got Ubuntu, right? And it's just make sure that everything is in place, and might take a few more times. So it's showing it's in the third step of 7-step process and so forth. And it's, as you can see, it's just running because I'm creating a new container now named web. It's actually running the apt-get install -y on top of the existing Ubuntu image, and it's building up a container pack for that particular image now, specifically for this docker compose. So this might take a little while, so we'll come back once it's done. Now the command is done. As you can see, it says Flask API default created, Flask API Redis started, and Flask API web 1 started, and so forth. So my containers should be up and running, and I should have my relevant images done. As you can see, all these commands have been run, so all good, and it has exported the layers and exported the image relevant to my containers as well. So let's now see Docker images. So if I use image-ls, it will show you this. As you can see, now I have a new image for my application named Flask API Web, and there is another image for Redis. So so this web name comes from the service name that I have given previously. So it's there. So now let's look at Docker PS to see what are the containers running. Obviously 2 containers are up and running already. Docker has come up with good names for that, and 2 IDs, and now the images are also mentioned. So let's go run our so to get the products, I think we used this command in curl. So let me try run that again, and in my case it should be 8082. Let's remember that. And as I expected, we don't have any products already here, so let's create a product. So as in this command, let me use that again. Make sure that I run it on 8082. I should get few details. Let me try to add another product here, just like how we did it in the last video as well, and giving it a different values just to make sure these are different products. Let me see. Okay, and this is the 2 different products, and I should now have 2 different products. And now let's try our company command, which is this, to see what we get. And make sure that you change to the relevant port, and as it's expected, company product masters has 2 products as expected, right? So that's because of the Redis cache that we already had. right? Let's remove one of the products, and let's see what happens. I think you'll have to use the delete command for that, this one. So let's remove one product, and I'm going to delete the product number 1. And yeah, so you should not have uh, two products now. Only the product with ID 2 should be there. Now I'm going to use the company command, and now as expected it just has one particular product already. So this is because of our Redis cache that we are having in our application. So it's a multi-container application. So this is exactly what we demonstrated with Docker Compose. So now so that's about the having the stuff up and running, and when you want to uh, shut down, we can just run this. And if you want to rebuild the images and run containers, you can also do this if you want to, right? So let's shut it down, and we'll close off this particular video. So let's see what happens when you do that thing. It's gonna say its container is removed, container flask is removed, and so forth. So let's go back and see docker ps, and no containers are running, and docker image ls, images remain as is. So if you want to run it again, you can just do docker compose up, and that will bring the containers up and running again. So that's all I was thinking to cover related to Docker Compose. There's a lot more to study on this, and I think this will be a very good starting point for you to learn about Docker Compose. Thank you for watching. So let's see in another video very soon.